Why is the pressure rising on my hydronic boiler? This is one of the most challenging service calls on a hydronic system because it sometimes takes days for the pressure to rise. Welcome to Boiler Room Detective. I'm your host, Ray Wohlfarth. My comprehensive series, 14 boiler books, covers everything from installation and troubleshooting to advanced system design. These are available now at Pronto Heating Supplies, TF Campbell, heatinghelp.com, and Amazon. Okay, detectives, let's discuss how much pressure we need in the system. Most pressure reducing valves from the factory come set at 12 psi. This is the typical pressure you'll need for a two-story building. You see, pressure, not the circulator, is what pushes water to the top radiators. 1 psi will raise water 2.3 feet. Let's say your highest radiator is 35 feet above the boiler. We would divide the 35 feet by 2.33 and get a pressure of 15.02 pounds. We add 3 to 4 psi as a safety factor, bringing our set point to 18 to 19 psi. Next, I would check the relief valve set point. Typically, it will be 30 psi, so we have an 11 to 12 psi cushion. When the water is heated, it expands and pressure increases by about 5%, assuming the expansion tank is sized properly. Another way of thinking about this is if you had a 35-foot high pipe filled with water and a pressure gauge at the bottom of the pipe, the pressure would read 15 pounds. If you tried operating this boiler at 12 psi, the top radiators will be filled with air and no water will be there as the pressure would lift the water to about 28 feet, not the 35 feet we need. Now we have two common reasons for the boiler pressure rising: pressure reducing valve or flooded expansion tank. In this video, we will be discussing the pressure reducing valve or PRV. The PRV, also called a fill valve or automatic makeup valve, is like a gatekeeper. It automatically adds water from your city supply to maintain the right pressure in this closed loop, preventing air pockets, pump failures, and inefficient heating. It's a good idea for a bypass or fast fill feature on the PRV. This allows you to quickly add water to the system. Never add cool water to a hot boiler. The fast fill feature is a lever on the pressure reducing valve that, when lifted, will allow water to enter at a faster rate. If the PRV does not have a fast fill lever, consider adding a bypass pipe with a valve around the pressure reducing valve. Filling a hydronic loop using just a PRV will take forever. Plus, it allows scale to build up inside the valve, possibly keeping it from closing tight. To increase the pressure setting, we have to loosen the locking nut and turn the screw clockwise. This part takes patience. I would start with a half turn and see where the pressure peaks. You can feel the downstream pipe of the pressure reducing valve or listen with the stethoscope. If the pipe is cold, it may be still feeding. The stethoscope will let you hear the water flowing. When done, tighten the lock nut so the pressure doesn't change on its own. A well-made PRV can last 20 years or more, but neglect it and corrosion and buildup will shorten its life. Here's your maintenance checklist. Aim for annual checks. Inspect for leaks. Look around the valve for drips or corrosion. Tighten fittings gently. Over-tightening cracks things. Clean the strainer. Many PRVs have a built-in screen to catch debris. Shut off the water, disassemble and clean it with a brush and water. Reassemble carefully. Monitor makeup water. Install a flow meter on the pipe feeding the boiler. If it's adding water often, you've got a leak somewhere. Fix it to avoid oxygen corrosion. Should we keep it open or closed? Experts debate this, and even two of the larger manufacturers disagree on whether to keep it open or closed. Keep it open. This assures the system always has water available. The drawback to this is you could be losing water and making it up due to a leak you never knew about. Another disadvantage is the cold water could feed into a hot boiler, causing tremendous damage. The argument for keeping it closed is if the system pressure drops, the top floor will be without heat. A positive is the cold water will automatically not feed into the boiler, doing damage. For glycol systems, keep the upstream valve closed to prevent dilution. And remember, be sure the boiler has a working low water cutoff.